Epistemic uncertainty. This is a type of uncertainty that comes from model's lack of knowledge. When the model has not learned enough about some situations, it becomes uncertain, not because the world is random, but because model's understanding is incomplete. The word epistemic comes from epistemology, which means study of knowledge. So, epistemic uncertainty literally means knowledge uncertainty. You don't need a Greek words or philosophy here, just remember like epistemic means knowledge gap. The core idea: epistemic uncertainty happens when the model sees something that is not well covered in the training data. If model learned from examples in one region, it is confident there. Outside that region, it's guessing more. So, epistemic uncertainty is basically I have not seen enough similar example. Those outside dots, like it can be like not seen enough data. This is where mistakes happen in the production. The most important property is reducible uncertainty. The epistemic uncertainty is reducible. Reducible means you can reduce it by learning more. Better data coverage, better model capacity, better training setup. If we collect more data from missing region and retrain, the model's uncertainty should go down. The key test here is if uncertainty reduces after learning new data, the uncertainty was epistemic. So for that, we need more data coverage. Now let's see. Epistemic uncertainty is not noise that permanently in this world. Noise-based uncertainty exists even if the model is perfect. Epistemic uncertainty exists because the model did not learn enough. Epistemic uncertainty does not mean that model is bad. It just means that model reached a knowledge boundary that is not enough. Good ML system treat this as a warning signal and behave safely instead of pretending confidence, and it always be reliable. Now let's try to cover a real world example, like a fraud model. A fraud model trained on last year fraud patterns, and it works well during training and testing. The model learns pattern from fraud strategies it's already seen, so its knowledge is historical. Now scammers invent a new fraud pattern that did not exist in the training data. This is a real life problem. Attackers adapt and the world changes, but model knowledge is stuck in the training distribution. The model still output prediction, maybe even in high confidence, but it is uncertain that in reality, because this region is unfamiliar. I'm drawing a cluster. Let me draw an area that is already model is aware about. This yellow one. Now outside this yellow coverage, like model don't know what these points are. This is unfamiliar region. So this is going to lead high epistemic. So how we can reduce this? We can collect more data and retrain and reduce this epistemic. So collect examples of new scam, label them, retrain and expand coverage. After retraining, the model should be more confident in new region because now it has learned so that's how this is reducible uncertainty in action. Collect to retrain and reduce epistemic. Okay, let's cover another example. Medical imaging model training, like we are using images from hospital A, like a sick person from hospital A. Even if the disease is the same, the data collection process can differ, like camera setting, scanner brand, lighting, resolution. So data is different. Now deploy the same model in hospital B, where equipment and image styling is different. This red one is hospital A and this data points of hospital B. This is not noise, this is knowledge gap. The model did not learn hospital B style properly. The model uncertainty should be high in hospital B because the input distribution is unfamiliar. This is why many ML models fail after deployment even when they looked good in training. The world is wider than the dataset. To reduce this, we need data from hospital B and retraining and adaptation. And after learning new style, uncertainty should reduce. I'm writing this like adding hospital B data. So we are making this knowledge wider and reducing this epistemic. Again, we are referring epistemic equals to knowledge gap. How to explain epistemic uncertainty to ML student? Think of training data as map. The model is confident where map has coverage. Outside the map area, the model is not truly reliable. This is like this in this circle, we are naming this as a knowing zone, and outside that we will say like unknown zone. So, epistemic uncertainty is basically a signal of low coverage and low knowledge. In production ML, the real job is often expand coverage safely over the time, not just train once and forget. Epistemic uncertainty matters because it tells you when the model is outside its comfort zone. Sorry. So now this reliable system should react more, slow down, and ask for review. It also tells you what data to collect next. High epistemic areas are your priority for retraining. This is how ML teams work. They use uncertainty signal to drive monitoring, data strategy, and safer decisions.